There's something about 3I Atlas that has been clear since the first observations. It doesn't behave like an ordinary visitor. Its activity fluctuates irregularly. Its jets change direction as if they were responding to internal triggers, and its appearance swings between the expected and the completely out of line. Recently, a new image made this strangeness even more evident, showing 3I Atlas in an unusual way as it approached Earth. Today, we're going to break down this new record and understand why this interstellar object keeps defying expectations. Since it first appeared on astronomers' radar, 3I Atlas has shown features that fall outside the pattern of comets from our cosmic backyard. One of the first behaviors that drew attention was the presence of jets projected toward the sun. In typical objects, solar radiation pushes dust and gas away from the star, creating tails that extend in the opposite direction. In Atlas's case, part of the material seemed to advance against this luminous push, which suggests the ejection of much larger particles, less affected by light pressure. That detail alone already indicated we were looking at something different from what we're used to seeing. Another striking clue was the so-called anti-tails, gigantic, well-defined structures, apparently pointing the wrong way, which stretched nearly 3 million kilometers. Extensions of that size aren't impossible, but they're not the usual scenario. One explanation researchers have considered is that 3I Atlas is releasing grains that are denser and more robust than those of comets formed on the outskirts of our solar system. If that's true, the dynamics of the material around it change significantly, and the effects of radiation and the solar wind start to act differently from what we expect. The object's thermal resilience also surprised observers. It faced perihelion under an intense bath of radiation and still showed no clear signs of breaking up in subsequent observations. For a body coming from interstellar space, which could in principle be more fragile, remaining intact went against predictions. Instead of a comet that falls apart when it nears the sun, we saw a visitor that held together. Add to that the out-of-pattern brightness variation, and the puzzle gets even more interesting. The photometric changes didn't fit the classic sublimation curves, which usually produce relatively predictable peaks as the object approaches and moves away from the star. In their place, Atlas showed abrupt oscillations, possibly indicating very localized activity regions, a complicated rotation, or even the irregular release of microscopic fragments. Images obtained after perihelion reinforced the unusual character of the jets. Observers recorded long, collimated beams with very well-aligned angles, almost in the direction of the sun. That precision suggests the activity isn't uniformly distributed across the surface. On the contrary, there seem to be very specific areas blowing out material preferentially. It's not something we've never seen, but here the sharpness and consistency of the alignment caught attention and added yet another layer to the list of peculiarities. The trajectory already offered the main clue to the origin of 3I Atlas. Its hyperbolic orbit points outward, consistent with a visitor from another star. Even so, its behavior during approach revealed interactions with the solar wind that were more dramatic than usual, affecting its dust structures in an uncommon way. To explain this, researchers have considered that the composition and surface texture of the object are very different from those of comets born in our solar system's environment. There's nothing here pointing to artificial manufacture or more extravagant theories. What we have is science, and the rare opportunity to study a body that formed in a distinct chemical neighborhood, perhaps under conditions quite different from those we know here. In other words, 3I Atlas is not an alien artifact. It's a sample from another cosmic laboratory, a messenger carrying in its dust the signatures of a distant stellar nursery. The beauty lies precisely in that. Instead of chasing extraordinary explanations, we can explore the extraordinary that exists in the very nature of an object made in another corner of the galaxy. Visually, the expectation would be a frozen rock shrouded in gases and dust. But recent photos added a surprise. A new image taken by an amateur astronomer using a DF3 telescope drew attention for the comet's flattened appearance. In the frame, the nucleus appears as an extremely narrow, luminous white streak, more a bright line than the diffuse point we'd expect from a conventional comet. Around it, there's a faint bluish halo, a soft, mist-like glow surrounding the central region. The contrast between the crispness of the nucleus and the delicacy of that blue sheen creates an aesthetic that's out of the ordinary. The light seems to wrap the center, as if layers were being illuminated in an unusual way, reinforcing the feeling that we're seeing something different. Part of that exotic morphology, however, has an instrumental explanation. 3I Atlas moves quickly across the sky, and the long exposure needed to collect enough light ends up stretching the signals recorded by the sensor. It's as if the motion reorganized the light, rendering the nucleus as a fine streak while diluting the surrounding glow, producing a more geometric effect. The final image looks almost like a technical drawing, but it's simply the natural result of a fast-moving body captured under specific conditions. In other words, the flattened appearance doesn't mean the object actually has that shape. It's a capture effect, a combination of exposure time, tracking, and the target's angular speed. As it continues its descent through near-Earth space, 3I Atlas has been brightening, which makes increasingly sharp images possible. Based on the available data, its closest approach to Earth occurred on December 19, 2024, at about 270 million kilometers. That's a safe distance, yet close enough to allow more detailed monitoring. Moments like this are valuable. It's not every day that an interstellar object passes relatively near and comes within reach of medium-sized telescopes capable of revealing fine structure in its jets and tails. As it crosses the stellar backdrop, subtleties emerge: small color shifts, variations in halo intensity, elongations caused by the combination of motion and exposure time. All of this helps map how the material is expelled, how it spreads out, and how it responds to forces in the space environment. Even so, the fascination remains. With each observing session, 3I Atlas has reminded us that the sky is always ready to surprise. In a setting filled with familiar patterns, a visitor appears that challenges models and forces us to refine our explanations. That's the most exciting part of observational astronomy. There's no need to invoke extraordinary hypotheses to be amazed. Nature itself, when it's born under different conditions, is more than enough to leave us brimming with questions. An object from another stellar system, with dust and ice made in distinct chemical environments, is a scientific gift. As it continues on its escape path and increases its distance, it will still yield clues about itself through the remnants of its activity and the evolution of its brightness. In the end, 3I Atlas works as a reminder that space is vast and diverse. Not every comet has to behave like the calling cards we've known forever. Sometimes the exception is the window we were missing to better understand the rule. And when that exception brings with it immense anti-tails, counterintuitive jets, out-of-pattern brightness variations, and images that seem to slip through classical definitions, we get the chance to adjust our lens and learn a bit more about how nature operates when it changes the manufacturing laboratory. As it moves away, the data collected by amateurs and professionals will continue to be combed for patterns, anomalies, and connections. If you enjoyed following this analysis, leave a like. That helps the video reach more people who are passionate about astronomy. And if you're not yet part of the community here on the channel, take the opportunity to subscribe right now. There's new content whenever there's something amazing to share about the universe. Thanks for watching, and see you next time.